Welcome to the DIY Honda Garage channel. The diagnostic trouble codes DTC P2237-16 and P2238 refer to an issue with the air-fuel ratio AF sensor, specifically relating to the IP circuit experiencing low voltage. This sensor plays a crucial role in the running of the vehicle's engine, as it measures the ratio of air to fuel being introduced into the combustion chamber, allowing the Powertrain Control Module (PCM) to make adjustments for optimum combustion. When its associated IP circuit short circuits to ground, the PCM identifies this abnormality and stores the DTC. The AF sensor is typically located before the catalytic converter in the exhaust system, and the PCM is found within the engine bay, often mounted in a specific bracket to shield it from engine vibrations. Proper functioning of the AF sensor is essential for fuel efficiency and performance. If not addressed, issues can lead to increased emissions and other related engine performance problems. The A4 sensor, also known as Sensor 1, directly influences the car's fuel efficiency and engine performance by measuring the air-to-fuel ratio in the exhaust gases. The Performance Control Module, PCM, uses this data to adjust fuel delivery and maintain optimal combustion conditions. The sensor is typically located in the exhaust manifold, where it can efficiently monitor exhaust gases as they exit the combustion chamber. A short in the intermittent power IP circuit leads to a low voltage reading, which the A4 sensor's built-in diagnostics will detect and signal the PCM to store the DTC P2237-16 or P2238, indicating that something is wrong with the sensor's power supply line. This malfunction can lead to issues like poor fuel economy or rough idle, making diagnosis critical for maintaining vehicle performance. Understanding both the location and function of the A4 sensor is crucial in identifying and rectifying the issue. Diagnosing DTC P2237-16-P2238 involves understanding potential causes, which can help pinpoint the exact source of the issue. First, the IP circuit could be shorted to ground, meaning there's an electrical fault somewhere along the wire that connects the AF sensor to the PCM, leading to incorrect voltage readings. Second, the AF sensor itself may be faulty. It could be due to internal damage or degradation over time, which affects its performance and ability to send accurate readings to the PCM. Lastly, if both the wiring and the sensor test normally, a malfunction within the PCM itself could be suspected. The PCM is the brain of the vehicle's engine control system, and issues within it can lead to incorrect processing of data, resulting in improper engine management. Each of these factors must be carefully inspected to effectively address the DTC and restore vehicle performance. Symptoms associated with DTC P2237-16/P2238 can manifest in various ways, primarily affecting vehicle performance. The most immediate indication is typically the illumination of the check engine light on the dashboard, prompting the driver to investigate further. Additionally, the vehicle may experience a noticeable decline in fuel economy as the engine compensates for incorrect air-fuel mixture readings. This inefficiency often results in increased fuel consumption due to the PCM's inability to optimize fuel delivery correctly. Another symptom may be a rough engine idle, where the engine may struggle to maintain a stable RPM when at rest. These symptoms not only indicate the need for immediate diagnostic attention, but can also lead to more severe engine performance issues if the underlying causes, such as a faulty AF sensor or wiring problems, are not resolved promptly. The first step in troubleshooting DTC P2237-16 is to inspect the external circuit linked to the AF sensor. It is essential to check for any signs of short circuits or open connections within the wiring. Begin by visually examining both the wiring harness and connectors of the AF sensor and PCM. If any frayed wires or corroded terminals are detected, repairs or replacements may be necessary. Utilize a multimeter to measure resistance across the circuit. Normal readings should show more than 1 megaohm to indicate no shorts. If the readings fall below this threshold, it confirms that there is indeed a short within the wiring. Properly diagnosing this step is crucial before proceeding, as issues detected here can save time and complications in further steps of the troubleshooting process. The second step in troubleshooting DTC P2237-16 involves checking the operation of the AF sensor itself. Given the nature of this task, it requires the installation of a known good AF sensor to determine whether the original sensor is faulty. After removing the suspect sensor, replace it with a verified working component, ensuring that the wiring plugs are secure and free of damage. Once installed, start the engine and monitor its performance. If the symptoms previously observed, such as a rough idle or poor fuel economy, persist, further diagnostics will be necessary, likely focusing on circuit faults or the PCM. However, if the installation resolves these issues and no further DTCs are illuminated, it confirms that the AF sensor was indeed the root of the problem, guiding you toward a successful repair. The final troubleshooting step for DTC P2237-16 necessitates inspecting the Powertrain Control Module, PCM. If the previous inspection steps have indicated normal results for the sensor and wiring, it suggests that the PCM may be at fault. Begin this inspection by checking all connections to the PCM for corrosion or tightness. If everything appears to be in order, consider running diagnostic tests on the PCM itself. This may include checking for software issues or communication errors with connected sensors. It's crucial to ensure that the PCM is processing information correctly to manage engine functions efficiently. If any faults are found in the PCM, it may require reprogramming or replacement, significantly impacting the vehicle's performance if not addressed. A thorough examination of the PCM is essential to conclude the troubleshooting process effectively. Once repairs involving the A5 sensor and any related circuits have been carried out, it's essential to perform a final verification of the repair effectiveness. Begin by resetting the Powertrain Control Module, PCM, to clear any stored DTCs. This step is necessary to ensure that any temporary faults indicated by the previous codes are erased and do not reappear. After resetting, start the engine and hold it at 3,000 RPM without any load until the radiator fan activates. Then let it idle. Monitoring the engine during this process is crucial to see if any symptoms reemerge, such as sporadic idling or the return of warning lights on the dashboard. A successful outcome would mean that the engine runs smoothly with no additional DTCs being stored, confirming that the repairs were effective. Preventive maintenance is essential in avoiding future issues related to the AF sensor and its circuits. Regular inspections of the AF sensor, including its connectors and wiring, can help identify potential problems before they escalate. Checking for signs of wear, fraying, or corrosion will ensure that the wiring remains intact and functional. It's also advisable to periodically test the sensor's operation to confirm that it is performing within specified parameters. Keeping the PCM updated with the latest software can prevent communication errors that may affect sensor readings. By incorporating these checks into routine maintenance, vehicle owners can mitigate the risk of encountering DTC P2237-16 or related codes, enhancing the overall longevity and performance of the engine. In conclusion, addressing DTC P2237-16 and P2238 requires a systematic approach to troubleshooting, beginning with assessing the wiring for faults. Identifying short circuits or damaged connections is crucial in determining the foundational issues affecting the AF sensor's performance. If wiring is functional, the next step is to analyze the AF sensor itself, replacing it with a known good unit to establish its operational effectiveness. Lastly, if the problem persists, the PCM may need inspection, potentially requiring reprogramming or replacement to rectify faults. Ultimately, a comprehensive understanding of each component and their interrelations is essential for effective repairs. If consistently maintained and monitored, these systems will function optimally and contribute to the performance and efficiency of the Honda CR-V. Please like and subscribe to the channel. See you next time.